All right, for 25 through 27, these are making sure that you can put it into this form where it's just raised to the t power and not raised to some number with the t, with the variable, and then give the percent of growth or decay. So all you really need to do is look at the number part. Ignore the t, and you want to say, all right, I need to figure out what 1.2 to the third is. So just use your calculator, 1.2 raised to the third power, and I get 1.728. So I'm going to rewrite this as y equals a times 1.728 raised to the t. Because all I've really done is I'm just thinking of this as 1.2 to the third raised to the t power. That still gives me 1.2 to the 3t. So we're just taking that number and putting it in with the base. So now when you look at that, this is now my b value. And what you have to decide is what's the percent increase or decrease. And all you're going to do is take the difference between this number and 1. So if I subtract 1, I get 0.728, which as a percent, I move it 2 places, I get 72.8%. So to find the percent increase or decrease, you're just looking at the difference between that number and 1. All right, so let's do this one. Again, we can ignore the 7. That has nothing to do with it. We're looking at the number piece of this. So we're going to group that together, and we're going to say, really, we're going to take e to the negative 0.012, and then we'll raise that to the t power. So e raised to the negative negative 0.12, sorry about that. Negative 0.12 power is 0.8869 rounded. So I'm going to say it's 0.8869 raised to the t. So again, all I did is I've grouped this. It's this number raised to the t power. I need to figure out the difference between that and 1. So if I take 1, and I'm going to minus that answer, so I go second answer, or just do 1 minus 0.8869, and I find out it's 0.1131. 0.1131. So it's the difference between this number and 1. Now, because it's smaller than 1, I have to take 1 minus that number. There's my decimal. Move it 2 places, 11.3%. We can just go to at 0.1%. All right, same with this one, except for now be careful because it's t divided by 5. So now I'm thinking of this as 0.9 to the 1/5 power raised to the t. Because again, that's t times 1/5, so the 1/5 has to come in here. So I need to take 0.9, raise it to the 1 divided by 5 power, and I get 0.9791. So now again, it's y equals that 14, that's just the start value, doesn't change, 0.9791 raised to the t. So again, it's decaying, I just need to figure out that difference between 1 and that number. So I hit 1 minus, second answer, second negative, and I get 0.0209. 0.0209. Or again, if I move it 2 places, 2.09%, you could say 2.1% if you want to round it. Any of those answers are fine. Okay, so get the number piece of it, raised to the t, figure out what that is, and take the difference between that number and 1. That tells you your percent increase or decrease. So this one was decreasing. I should probably put decay. This one, the number was less than 1, so it's getting smaller, decaying. This one, the number was bigger than 1, so it's increasing, so it's a growth. So this one was growing, these other two were getting smaller, or decaying. All right, the other one I wanted to go over, this is actually on the non-calculator part, making sure you can find an exponential. So most of you did it with charts, and you said, all right, if these are going up by 1s, what do I have to multiply 7 by to get to 21? I have to multiply by 3. So that's your base. So I know my base is 3 in my exponential, so it's going to be 3 to the x power. I have to figure out my start value. So to do that, we have to go backwards. So we had 21, and you can do this with your calculator. You can say, all right, I started with 21, hit enter. Then my base is 3, so to go backwards, I'm going to divide by 3. Hit enter. I got 7. Hit enter again. When I divide by 3 there, I get 2.3 repeating. And if I hit enter again, I get 0.777 repeating. I want to see what that is as a decimal. So remember, we can go to math. I'm going to hit enter on convert to a fraction, and I get 7/9. So this number is 7/9. So we really just took this and we're dividing by 3. So 7 divided by 3, I could just leave that as 7/3 if I want to. Divide that by 3 again, I would get 7/9. But you can use your calculator to go backwards. So that's the start value. Y equals 7/9 times 3 to the x. And I guess I did say this was non-calculator, correct? We will not put numbers quite that crazy on there. The numbers we have will be nice numbers, like I believe this one. So let's talk about this one. So this one, you're going from 1 to 3. So now you have to multiply by b and multiply by b again to get to 4. So what do you multiply 36 by to get to 4? You multiply by 1/9. So in order to go in between there, I'd have to multiply this by 1/3, and then take that answer and multiply it by 1/3. That would get me to 1/9. So because this skipped by 2, I realized that, oh, this goes to 1/9, but now I know each of those have to be 1/3. So if I take 36 times 1/3 divided by 3, I get 12. And then 12 divided by 3. So then I have to go backwards and say, what would this number here be? Well, really going backwards, I'm multiplying by 3. So if I think about what 36 times 3 is, I think I get 108. So my start value is 108. My base was 1/3 raised to the x. Now again, most of our numbers are going to be a little bit easier than that, but the process is the same. Figure out what you had to do to go from 36 to 9. What do you multiply by? If you skipped one and went by 2s, that means you have to figure out what each of those are to get there. So really you're taking the square root of 1/9, which is 1/3 is your base. And then you have to figure out how to go backwards to get to that 0. The start value is always when x equals 0, what's the y value? That's your start value. Your base is what are you multiplying by each time to get to the next number. Okay, and then the last one real quick is the stats one, where again, this is a calculator one. You'll go to Stat Edit. Under Stat Edit, remember the Stat button's right here. You put in your L1 and your L2. You should be able to go to your Stat Plot. Make sure that it's on. If it isn't, go in, turn it on. It should be a scatter plot with lists 1 and 2. Remember, you go to Window. You want to make sure the x's are you can see. So I went from 0 to 10. That'll take care of all my x's. My y's have to go from somewhere up to about 240. So I went from 0 to 250. Make sure nothing's in my y equals, and I hit graph. Now here's the deal. If it looks like this, that's a natural log graph you're going to use, the LN regression. If it looks like this, where it's getting bigger this way, that's an exponential regression. Okay, so you're looking if it's getting big real fast, that's exponential. If it's getting big and then slowing down, that's a natural log. So this one looks like a natural log. So I'm going to go to Stat. I'm going to go over to Calculate, and I'm going to go down to the natural log, LN. It's not the LIN, that's linear. It's natural log. So I hit natural log. I'm going to say list 1, comma, list 2. That's where my lists are, comma. Remember, we go to vars, y variables, function. Now you don't have to do any of this. It's just for me to see what it looks like. So there's my equation. That's all I care about. A is 51.4. So I'm going to write y equals 51.4 plus b. B was 94.5 times ln x, the natural log of x. So there's a plus b times the natural log of x. And again, you did not need to do the vars thing. All you really need to do is stats. You can actually just do stats, over to calc, go down to that linear regression, and hit enter. You don't even have to put L1 and L2. It does that. And it gives you your answer here. You're done. You don't have to do anything else. You don't even have to look at the scatter plot unless you just need to see is it exponential or a log. When I hit graph now, there's my equation. And it's a pretty good fit. So that's just to check it. But really, all you need to be able to do is put this in list 1, put that in list 2, decide if it's a linear or it's an exponential, and then hit the regression, do the stat calc regression, and write me the equation. It does say how long will it take to reach 250 bushels, so that's the y. So we've already talked about this, but now you need to solve that equation. You'll need to subtract 51.4, divide by 94.5, and you'll get the natural log equals something, whatever that is, minus 51.4 divided by 94.5. You get natural log is equal to 2.10. So then you have to go e, natural log e, raised to the 2.10 equals x, and then get what that answer is. So you do actually have to do a little bit of math to get to that answer. It's like 8.2-ish, I think. And we're in years. So you do have to end up solving it like we did the other equations as well.